Assalamualaikum. My name is Sharfana Afrina binti Said Yusof and my metric number is BE40301. So in this video, my group member and I will explain about the protective relay. So here is my group members. So first is Siti Hajara binti Abdul Aziz Krish. Next is me, Sharfana Afrina binti Said Yusof. And last one is Wong King Kang. Now I will explain about what we will do for this activity. So first, we make a connection for the relay in three-phase network. Besides that, we observe and also analyze its behavior with respect to under voltage and over voltage condition. And lastly, we measure the operating time of the relay with respect to various settings. Now, I will explain what is DTR and ITR. DTR stands for Definite Time Relay and ITR stands for Inverse Time Relay. Both relay detects an overcurrent in the circuit and give tripping command to operate the circuit breaker for isolation of faulty network. What is DTR? DTR is a relay that operates after a definite period of time once the current exceeds the pickup value. In other words, it operates with some delay. The delay is adjustable, and the operating time does not depend on the magnitude of the current above the pickup value. A time delay mechanism is provided to get desired operating time, and they are used when the impedance between the source and the relay is smaller compared to the line impedance. Besides that, they also used to serve as a check against short time asymmetrical current. Next is ITR. So ITR is a type of relay that have an operating time depending on the current, generally with an inverse characteristic. As you can see here, the graph characteristic of the ITR. So the operating time of the relay is smaller as the current gets larger. So as you can see here, when the current is larger, the operating time becomes smaller. In normal practice, when it is nearer to the pickup value, meaning that if fault current is equal to the pickup value, the relay will take infinite time to operate, and it become less inverse as it is increased. So ITR are used when the source impedance is smaller than the line impedance. That's all from me. Thank you.
Assalamualaikum to Dr. Suryana. My name is Siti Hajara binti Abdul Aziz Krish. My metric number CE190033 and I am from group A 4.5. So I will continue to explain about the connection of the system DTR. In this activity, we need to use a three-phase supply, the voltmeter, the relay for over voltage and under voltage, and also we need to use the buzzer. This is a three-phase supply. Actually, the connection for the L1, L2 and L3 is direct to the L1, L2, L3 at the relay. So, L1 is a red, L2 is a yellow and L3 is a blue. Then we have a voltmeter to measure how much the voltage is at this activity increase. So voltage measurement, we need to connect it in parallel. So take the L1 and L2 from the three-phase supply direct to the voltmeter. When all the connection of the component is done, we stop. We don't start this system, but we need to increase the voltage until 380 volt line to line. After that, we connect the buzzer before we start the system. So in this experiment, we want to show if we increase the voltage, the buzzer will turn on. When it get to a point, the buzzer will alarm, and at this time we can take the reading of voltage operating. After that, slowly decrease the voltage until the alarm turn off, and then take the reading of voltage release. This is for over voltage. For under voltage, first we need to decrease the value of voltage until the buzzer turn on, and that is the voltage operating. Then increase the voltage until the buzzer turn off, and that is the voltage release. After that, the connection of the system ITR. For ITR activity, we need many components like three-phase supply, circuit breaker, the transformer, the ammeter, the relay, the load, and the buzzer and the load. So connection of this equipment is first connect the L1, L2, L3 and neutral to the circuit breaker, and then this is the connection from circuit breaker to transformer. After that, the arrangement of the transformer is in delta. So get out here, get in Y, get out of here, get in B, and get out of here, get in R. Then this is just connect to the neutral. This one connects to the ammeter. If we want to measure the current, the ammeter must connect in series at the circuit, and the output of the ammeter connect to the relay. The output of the relay connect to the R1. Same for the second phase. So for this Y direct to this, and this go to R2, and for this one get into this, and the output go to R3. The other things is the relay need to supply the power, so the connection of supply can take from the L3 and neutral at the three-phase supply and connect to the relay. And the last is connect the buzzer. So this is the connection system of ITR. I think that's all. Thank you.
Hi, Dr. Suliana. My name is Wong Chin Kang. Can call me CK. My metric number is AE180110. I'm from Group A4.5, and now I will continue to the presentation for the result and conclusion. The result for Activity 1, resetting ratio of under voltage or over voltage time relay. At the under voltage operation, the operating voltage VO is 360 volt and the relay voltage VI is 377 volt. At the over voltage operation, the VO is 408 volt, the VI is 402 volt. Since we get the VO and VI, we can start to calculate the resetting ratio KR. The resetting ratio can be calculated by using the formula release value divided by the operating value. So at the under voltage operation, the KI is 1.03, and at the over voltage operation, we get the KI is 0.99. After we calculate, we record down the KI into the table. The result for activity 2, inverse time over current relay. We set the recessive load to 7, 6, 5, and 4. After that, we record down the ampere and the trip time measure. After we record down these two data, we can start to calculate the trip time in theoretical, so that we can compare between the trip time theoretical and the trip time measure. So the trip time calculator can be calculated by using this formula, and this the I bigger can be used is equal to 0.5 multiplied the IN. So when the IN is 1, we can can get the 0.5 ampere, and we put it back into here, and we can start to calculate the trip time calculator. So this is the trip time calculator we get, and we record out into the table, and later we do the comparison between the trip time calculator and the trip time measure. So the conclusion, to sum up the experiment, we are able to learn how to connect the under voltage or over voltage time relay and inverse time over current relay in three-phase network. From the connection of under voltage or over voltage time relay in the three-phase network, we are able to investigate the behavior with respect to under voltage and over voltage condition. Furthermore, we also learn to measure the operating time of relay with respect to different settings from the connection of inverse time over current relay in three-phase network. That's all my presentation. Thank you.